So over a year ago, I made a video about how to get into OS dev. But looking back, that video kind of sucks ass, and a lot of people have been asking me that question more recently. So I thought I'd make a new, definitive version based on my experience so far, right? Now, despite what many people believe, making an operating system isn't like this impossible, superhuman task that's just, too fucking far out for any single person to do on their own. I mean, it's one of those things where you can keep going more and more, and you can keep making progress and adding features and expanding like what you want in there, right? But it'll take you fucking forever. It'll be pretty much impossible to manage, right? The good thing is that with any other software projects, if you start small and you keep your scope sort of limited just to start out, it's really not that complicated of a process. I would say that before you actually start with, writing any code or anything like that, there are a few like prerequisites you'd have to learn before you get into it. And this is something that I didn't really, stretch the importance of in my original video. That I only sort of realized like now looking back. If you want to make an operating system, you have to learn assembly. You don't really need to be like some super expert in it or anything like that. You just need to be familiar with the language, any assembly language really. You need to be familiar with, how registers work, how certain instructions work, how jump labels work, condition checking, and all that shit, right? It's, cause, you need to learn this for multiple reasons. One, you have to use assembly to make an operating system. Even if you want to write as much as it in C, C++, Rust, whatever, right? You have to do some basic assembly to, to load the actual kernel in, right? And even apart from that, there is a plethora of tutorial content online from like old OS dev forum pages and shit like that. Or like old like example code, like all these things, drivers, or just like regular like operating system routines. A lot of it's going to be written in assembly, and if you can't understand assembly and you can't, you know, translate it well enough over to C or C++, and you can't understand what's going on, and you have no idea what the code does in the first place, you're probably better off learning assembly before you continue developing any further, right? And even then, I would still, if you don't want to go into OS dev after watching this video, I'd still recommend learning assembly. I think it'll just make you a better programmer overall. I mean, even allocating data, just normal stack memory, in any other given language, it'll just be int A and B, whatever, right? But in assembly, you have to consciously think about, like, okay, I'm telling the program to go all the way over in memory to access this data. I'm telling the program to go all the way over here. I'm allocating this much over here. Let me do lists first so I can just do lists and not have to not have to do anything with memory, or as little with memory as possible. So all that data doesn't have to travel across the bus, right? I mean, just this, or knowing like what certain conditions to check given certain operations. It's like a very useful intuition to have when you're making even higher level programs. And I just recommend it regardless of whether or not you want to go into OS dev, but especially if you want to go into OS dev. And keeping on the topic of assembly, there's also abstractions you're going to make when designing an operating system. Pretty much like 95% of the stuff you're going to do where you're talking to hardware and controlling hardware with software is going to be some, high-level language, C or C++ abstraction over LB or NB instructions, right? Or, either it's messing around with hardware ports or it's calling some other routine you already defined in some assembly file for hardware communication. And even beyond like hardware communication and like assembly stuff, you're still going to be making abstractions on top of abstractions on top of abstractions for a lot of different stuff, from, writing your own file system or, basic stuff like video drivers and implementing them into some like GUI framework you're making, right? So ideally, you would also be very familiar with abstraction and software architecture before you really get into designing an entire operating system. Because the architecture of like the actual operating system itself, how it's planned out, how it's designed, not just the code organization, but specifically like, do you want to design a microkernel? Do you want to design a monolithic kernel? Do you want it to be Unix based? Do you want it to be like support like system calls and be like POSIX compatible or whatever the fuck, right? I mean, you could just do like a cursory reading of like OS theory and stuff like that, and get it like a general idea of how operating systems are designed. Obviously, a lot of this is going to be based on like, are you making it for an embedded environment or a desktop environment? What is the purpose of the operating system? Is it just going to be a general user desktop operating system, which most hobby OSs are like made to be? Or do you want to make something a little bit more niche and a little bit more specific, right? I mean, it's, like get like a piece of paper and write down like the shit you want it to be, or like what ideas you have for it, or what you want it to be, what purpose you want it to serve. That way, 2, 3 months from now, when you're writing code, you don't, realize that the organization is fucked up, or you wrote something or followed some tutorial that doesn't fall in line with how you originally want it to be, so now you have this tangled mess that you have to work backwards on. But once you do get all that stuff squared away, you can actually hop into development itself. And if you have absolutely no idea, even if you don't know what you want to make exactly, you just want to test out like making your own operating system, the first thing I'd probably recommend is checking out the bare bones tutorial on OS Dev. If you look up like OS Dev bare bones, you should find it, or I could link it, right? It basically goes over, assuming you're going to be working with like C, the GNU compiler, Grub, all that shit. All the tutorial goes over is basically just making a very basic bare minimum kernel and loading it into memory. It'll go over how to link everything from between the C and the assembly, what compiler flags to use, how Grub works, and how it's going to be built in your disk image, right? From there, you could decide to go further and, figure out how to write stuff to the screen by, writing some information to a certain spot in memory and print, certain characters with colors to the screen. From there, you'll go through like hardware support and learning how to write drivers and going through things like interrupts and writing an interrupt manager and shit like that. When you're first starting out, don't expect to get to the fun stuff immediately. I mean, it's a very uphill battle to get even the most basic stuff working, such as keyboard support, right? Let alone a graphical environment and, a scheduler and multitasking and things like that. Once you do get over that, initial hurdle, it is sort of linear progression depending on how much you want to write from scratch or implement yourself. Like if you want to write your own file system or graphical environment, those are other smaller hurdles you have to get over. But, even if you don't want to do that, you could start off with just, modifying the Linux kernel or using other people's drivers and other people's, operating system routines, libraries, all that shit. It's really like, because the great thing about OS Dev is that you can go as deep as you want to or as shallow as you want to, and still, it's basically up to you to get to the part where you want to enjoy it and where you want to make it your own, right? You don't have to do everything from scratch. You don't have to use other people's code or implementations, right? It really is like a very... You're allowed to do what you want. You could be as, free to do whatever the fuck you want. You could be as creative or stupid as you want or whatever, right? It's a very nice thing to get into when it comes to software, especially relative to like a lot of other software where you're limited to dependencies and certain libraries or certain operating systems and platforms. It's good to have like be in like a development environment where you could really just make something of your own and have it exist in its own sort of universe, But going back to OS Dev again, OS Dev is probably going to be your primary source when it comes to a lot of operating system things, whether it's reading about theory, copying tutorial code, or just like reading about some driver implementation details or how to control some piece of hardware. It's really going to be like your primary source for everything. It's going to be the first place you look. Like if you want to learn about a historical event, you go to Wikipedia, maybe, just to check it out, read like a summary. Then you'll find your own sources and dig deeper into it, right? It's the same thing with OS development. You're going to go to OS Dev first before, any other place. Then if you want something more specific, you might go to some guy's GitHub page or some guy's blog or something else like that, right? But once again, the OS Dev wiki is something you want to keep bookmarked, if you really want to get into OS Dev. They also got a forum that you can go on, make an account, ask questions. I've never used it personally, but there have been some pretty useful threads there before with like pretty useful solutions and common answers to bugs and shit like that. So once again, the OS Dev wiki is going to be your saving grace basically during much of your development, especially at the beginning too. And even if you don't want to follow the bare bones tutorial that they have on there, you can still look into like options for other bootloaders, options for writing your own bootloader, options for writing something based in Rust or some other compiled high-level language other than C, right? I mean, if I can do it, then you could probably do it too. Having experience does matter, and it'll definitely make the process easier. But everybody does something for the first time before, so it shouldn't be like this scary, incomprehensible thing to work on. Just like start out with basic tutorials, start out with reading about it. Even Wikipedia itself can be a good source on like a lot of operating system stuff. Look at other hobby projects, look at other mainstream operating systems, look at how they're designed. Because at the end of the day, if you're making an operating system, if you're making a compiler, if you're making a browser, if you're making a game engine, or any of these like really hard things to do, it's not impossible, I mean, it's definitely a lot of work, especially if you want to get deep into it and make it worth. If you want to make it stand out, you really have to put a lot of work in. But it's software at the end of the day. Humans made it. You can make it too. The great thing about software is that unlike electronics or other types of like traditional engineering, you don't have to buy a bunch of materials and like get like some like city approved shit going on before you realize, oh wait, this is actually not what I wanted it to be. The only thing it costs is your time and your energy at the end of the day.